Hello friends, welcome back to our session on CSAT paper. Yesterday we have seen some of the problems. So today we will start with the next problems. So problem number 46 here. If n is a natural number, then what is the number of distinct remainder of 1 raised to n plus 2 raised to n when divided by 4? So n is a natural number. How to tackle this problem? Now we have to see this 1 raised to n plus 2 raised to n. So here we will just see what are the different values for this. 1 raised to n, 2 raised to n. So n is a natural number, so we can start with n as 1. So when n is 1, it will be 1 raised to 1 plus 2 raised to 1. So that will be 3. And when divided by 4, what will be the remainder here? Remainder will be 3. 3 is the remainder. Now next n is equal to 2. So it will be 1 raised to 2 plus 2 raised to 2. So 1 raised to any power will be again 1. So 2 raised to 2 is 4 plus 1, 5. So when divided by 4, remainder will be 1. Okay. n equal to 3. 1 raised to 3 plus 2 raised to 3. That is 8 plus 1, 9. So divided by 5, by 4 will be again 1. Now if you observe here, see after this 2 raised to 2. Okay, whatever you go on increasing the powers of 2, it will be a multiple of 4. Okay, so it will be divisible by 4. And here it is 1 always. So the remainder for the next things will be always 1. For any power of 2, it's like 2 raised to 4, it will be 16. 2 raised to 5, 32. 2 raised to 6, 64. They will be all divisible by 4. Okay, so the remainder will be 0. 1 divided by 4, the remainder will be 1. So there are only two remainders in this case. One is 3, another is 1. Okay, see all for all other values, it will be 1 only. So we have been asked the number of distinct remainders. So there are two distinct remainders. One is 3, one is 1. So the answer here is 2. Okay. This is clear. So option number C. This is the 46th question. Now the next question 47. Let P is equal to QQQ be a 3-digit number. That means all the 3 digits are same. What is the HCF of P and 481? So for finding out HCF, we will have to find out the common prime factors and find out the product of them. So see, first we will see the factors of 481. So for 481, okay, you will have to start with 2. It is not divisible by 2. It is not divisible by 3. Not divisible by 5. So not divisible by 7 also. I think 7, 6 are not divisible by 7. So next one is 11. It is not divisible. 13. Yeah, 13 it is divisible by 13. So 13. 3 is 13, 9 and remaining is now. So into 7. So 13 into 37. So 481, the two factors are, prime factors are 13 into 37. Now we will see this QQQ, means all the 3 digits are same. Okay, so what is the HCF of P? Suppose see P is equal to 111. Okay, so 111, the factors are 3 into 37. So if you see this 481 and 111, the HCF, the common factor, only common prime factor is 37. So HCF will be 37. Now 222. Suppose see QQQ means 222. Now here the factors will be 2 into 3 into 37. But again the common factor for 481 and this 222 will be 37. So likewise any multiples of 111, it will be just say 3 into this, 4 into this, 5 into this and again. But the only common prime factor, it will be 37 and 37. Okay. So HCF will be 37. So this QQQ and this P, the HCF is 37. So option number C. Because HCF is the product of the common prime factors. See, if you observe here, many questions are based on HCF, LCM, then the indexes or the prime numbers, number system basically. So please go through it properly, make the concepts clear. What is the 489th digit in the number 1, 2, 3, 5, 4, 5, 6, 7, 8, 9, 10, 11, 12 and so on. That means all the natural numbers are written in this order. Now here the 489 digit. Now we'll go by digit. So single digit numbers, then 2-digit numbers, 3-digit numbers and so on. Now we know that there are 9 1-digit numbers. Okay, 9 single digit numbers. Or rather I will just write it here. So single digit numbers there are 9 and there will be 9 digits. So 9 into 1, there will be 9 digits. Now there are 92 digits number. Okay, so 2-digit number. There are 90, so 90 into 2, that is 180. So up to this stage, see, single digit and 2-digit, 189 numbers. Now we want to have the 489th number. So 489 minus 189. See, 489 minus 189, that is 300. It is 300. So now we have to find out the next 300th number. Okay, now we know that, see, this is 90. Now next 900 numbers will be 3-digit numbers, starting with means 100 to 999. Okay, so they will be 900 numbers. Now the 300th number, okay, so 300 3-digit number. Okay, the first 3-digit number is 100. The second digit is 101, third is 102. Likewise, the 300th number. Okay, so 300, the digits we want. So actually, here this one we will be having only the 100 3-digit numbers. Okay, sorry, we want 300 digits. Okay, and so 100 3-digit number here. Okay, so sorry, 300 digit we want. Okay, so 100 into 3, this will be 300 digits, 300 plus this, 489. So the unit place digit of the 100th digit will be the 489 digit. Now the 100 digit number will be 199, and then the unit place digit 9 will be the digit of the 489 digit. Okay. See, 9 digits, 180 digits, then this 300 digits. So total 489 digits. And the last digit or the unit place digit of this 100th number is 9. So our answer here is 9. Okay, so just basic number system here. Okay, single digit numbers, 2-digit numbers, 3-digit numbers, and so on. We'll go for the next problem. A mobile phone has been stolen. There are 3 suspects, P, Q, and R. They were questioned knowing that only one of them is guilty. The responses are as follows. P said, I did not steal, Q stole it. Q is saying, R did not steal, I did not steal. R said, I did not steal, I do not know who did it. Now, who stole the mobile phone? So, from the responses of these persons, we have to find out who has stolen the phone. Now, here in this type of questions, guilty or non-guilty, truth or lie, etc., the basic assumption will be the person, okay, who is innocent, not guilty, he will be telling all the truths. Okay, he will be not telling any lies. And the person who has stolen, or the person who is guilty, he will be telling lies here. So we will be using these 2 concepts and these assumptions. Now, see, there are 3 persons, P, Q, R. We will see one by one. If P is guilty, what will happen if Q is guilty, and if R is guilty. There will be 3 cases because only one person is guilty. Now, first, if P is guilty here, P is guilty. Okay, guilty. Guilty person is P. Then what he is saying, I did not steal. Okay, so naturally, if P is guilty, he will be telling lies. So I did not steal and Q stole it. Both are lies. Because now, if P is guilty, Q is not guilty. So Q and R are innocent. So Q stole it is also a lie. So which is consistent with our assumption that if a person is guilty, he will be telling lies. Now see Q. Q is telling R did not steal. Because Q is innocent now, he will be telling truth. He will not be telling any lies. So R did not steal, that is correct, true. And I did not steal, that is also true. Again, R is saying I did not steal, which is true, and I do not know who did it. That is also true. So by this, P is guilty. Same way, we will see just assume P, Q is guilty and R is guilty. What happened? Suppose if Q is guilty, that means Q will be telling lies and P and R are innocent. They will be telling truth. So P says here, I did not steal it. So that is true. Q stole it. That is also true. But what about Q? Now Q is a guilty person. So whatever he is telling, it will be lies. So R did not steal. That is also a lie. Okay. And I did not steal, which is a lie because he has stolen it. So whatever he is telling, I did not steal, will be a lie. So that cannot happen. There is a contradiction itself. Same way if R is guilty, okay, I did not steal, I do not know who stole it. Okay, so that will be lie, means both the statements are lie, but Q is innocent and he is telling that whatever he will be telling, it will be a truth. but he is saying here R did not fail. So which is contradictory to the assumption. So which cannot happen. That means Q and R are not guilty, but P is guilty, as we have already seen. So P has stolen the phone. P, option A. So next question. Three teams P, Q, and R participated in the tournament in which the teams play with one another exactly once. A win fetches a team 2 points and draw 1 point. A team gets no point for a loss. Each team scored exactly 1 goal in the tournament. The team P got 3 points, Q got 2 points, and R got 1 point. Which of the following statement or statements are correct? The result of the match between P and Q is a draw with the score 0-0. The number of goals scored by R against Q is 1. Which of the statements given above is correct? So we'll see this. Now see, the person is getting 2 points for a win and 1 point for a draw, no point for loss. See, P has got 3 points. That means P, see, if you see this, wins, draw, and losses. Okay, so win, draw, and loss. Okay. P has scored 3 points, which must be from winning 1 match and drawing 1 match. He has not lost any match here. That means. Okay. Then Q. Q has scored 2 points, which can come from 1 win or 2 draws. So it can be either 1 win, no draw, no loss, or it can be no win, 1 draw, and this 1 loss. Okay. See, either it can be 1 win and no loss here, means 1 loss. 1 second. T has got 2 points. So 1 draw, it cannot be draw, and 1 loss. See, out of 2 matches, he has won 1, he has lost 1. Okay, or it can be to both the draws. So 1 point from each draw. So 2 points. So for Q, this is the thing. For R, he has not won any match. Okay, but still he has got 1 point. So that must be 1 draw. So no win, no, and 1 loss, of course. It will be 1 loss. No win, but for him. Okay. Now we'll see here. See, now P has won 1 match, drawn 1 match, and lost. No, does not lost 1. So now we will see basically the 3 matches. See, 1 match will be PQ, another match will be QR, and 1 match will be PR. Okay, this will be 3 matches. Okay, PQ, PQR, and PR. Suppose here we assume that P has won against Q and drawn against R because R has drawn 1 match. Okay, so if that assumption, see P won and R lost. See P, Q. Okay, now so exactly they have scored 1 goal each. To win a match, there should be at least a difference of 1 goal. So if P has won against Q, the goals should be 1 and 0. Because P has scored only 1, so Q cannot score anything. And then draw with R. So it may be P and Q, the goals I am writing here, P and R, 0-0. Okay, so 1 win, so he will get 2 points, 1 draw, he will get 1 point. And the goals, 1 goal for P up to this stage. But now see here, P and Q. Now Q has lost against P, so he must win against R. Okay, so in this QR match, Q and R, it will be 1-0 goals. See, I am writing of this goals. Okay, and loss now, loss against Q. Okay, so here Q has scored 1, R has scored 0. Okay, but now if you see this, see P and R match. Okay, against in this P and R match, it will be draw 0-0 goals. Okay, I'll just write it here instead of this. But now for this assumption, see R, there is no scope for R to score any goal, which cannot happen because R has also scored 1 goal. See, his points are okay, but that means this our assumption that Q has won a match is wrong assumption. So that means Q has drawn the matches. So now we will see that what happens if Q has drawn the matches. Okay, so I'll just clear this or I will write it here. So P and Q, and once P has drawn with Q, Q has drawn with R also. Okay, so R has drawn with Q, and P and R as 1. So see P and Q. Okay, so it may be either 0 goals or 1 goal. Now we are picking this two draws and same way Q and R. It can be either 1 goal or 0 goal. And P and R. See, P has won the match, R has drawn here and lost with 1. So it must be at least 1-0. So in this P is 1 with R. Okay, he has scored 1 goal there. That means now his total goals are over. So this possibility is not there. Okay, that means the possibility will be P and Q have drawn the match and they have scored 0 matches here. Okay, now see, against P, Q has not scored any goal. So now he has to score his goal with against R only. That means this possibility is also not there. Okay, 1-1 or 0-0. Sorry, this possibility. Because he has to score 1 goal. Okay, so this is correct and this is correct. Okay, so what has happened is P has won against R. Okay, scoring 1 goal. Okay, so P got 2 points, R got 1 point. P has drawn against Q, so 0-0. So 1 point here for P. So total 3 points. 1 point for Q here. And in the draw of Q and R, they have got 1 goal each and 1 point each. So it tallies. So here, see this, the two things. The number of goals scored by R against Q is 1. That is true. This first statement is true. And this is also true. See, the result of the match between P and Q is a draw with the score 0-0. See here, 0-0. This is the case. So both the statements, 1 and statement 2, both are correct here. So it will be both 1 and 2. Option C. So like this, you'll have to consider who has won against whom and this. So you'll have to check all the possibilities. So we have ruled out this possibility and remains this. Okay, next. P is brother of Q and R. So this is based on blood relationship, family relationship problem. P is brother of Q and R. S is R's mother. T is P's father. How many of the following statements are definitely true? So here also just we will have a family chart or tree. See, P is brother of Q and R. So P here, so Mary, brother of Q and R. That means they are the children of the same couple, same family. Okay. T is P's father. So T is father here. And S is R's mother. So S is R's mother. So mother. So T and S is a couple. They are having 3 children. P a male. No, means nothing is said about Q and R's gender, whether they are male or female. It is not mentioned. Okay? Because P is brother of Q and R. That means P is definitely male. But Q and R may be either sisters or brothers. So that is not clear. Now we'll see one by one. S and T are a couple. So it is true. First statement is true. Q is T's son. Now we cannot tell. Q is T's child, but we cannot tell whether he is son or she is a girl. So this is not correct. T is Q's father. That is correct. So third one is correct. S is P's mother. That is also correct. R is T's daughter. Again we cannot tell because we don't know the gender. So whether daughter or son we don't know. So this is not correct. Always correct. Not definitely true. It may be true. See, there is a possibility for second also. You may be P's son, but not definitely son. Because the question is, which statements are definitely true? And the last one, P is S son. P being a male, this is also true. So statement number 1, 3, 4 and 6. 4 statements are true. So here only 4. Option C. See, you have to be very careful about the wordings. How many of the following statements are definitely true? Or the question would have been how many of the following statements may be true. So maybe means all the 6 may be true. But definitely true only 4. Okay, now one coding question here. If NO is coded as 210, NOT is coded as 4200, NOT note is coded as 21000, then how is notes coded? So if you carefully observe in such type of cases, the position of the letters in the English alphabet is used. like A is 1, B is 2, C is 3, and so on. Z is 26. So for this, if you take this NOTES, okay, so here I will just write their positions. So N, see A, B, C, D, E, F, G, H, I, J, K. J is the 10th one, K, L, M, N. So N is 14, then P, O is 15, then T is 20, E is 5, A, B, C, D, E, and S is 19. So these are the positions, A, B, C, D, E. Now NO is coded as 210. So NO. Okay, here what they have done is the product. NO means 14 into 15. That is 210. Okay, next T is added. So NOT. It is 14 into 15 into 20. Okay, so it is 210 into 20, which is 4200. Okay, I think it is clear. Then next one, NOTE, note. So 14 into 15 into 20 into E is 5. So 4200 into 5 is 21,000. And the last S, so notes. So 14 into 15 into 20, 5 is E into S is 90. So if you multiply this 21,000 into 19, 19 ones are 19, carry 1, 19 twos are 38 plus 1, 399,000. So here the first option. Okay, so many times in the alphabet, in the positions of the alphabets is used in the English alphabet, either from the forward side means A is 1, etc., or backwards. That means in that case Z will be 1, Y will be 2, and A will be 26. So please be comfortable and familiar with the English alphabets, A to Z. Okay. Again, another question on coding itself. France is coded as 654321. Germany is coded as 9158437. I think the question is missing. Some part is missing, I think. Okay, anyway, just we'll see. We'll see that later on. I think the question, some part is missing there. Okay. The 5-digit number PQRST, all distinct digits, is such that T is equal to 0, P is thrice T, S is greater than Q by 4, while Q is greater than R by 3. How many such 5-digit numbers are possible? Okay. Yeah. 58. PQRST, all distinct digits are there. So we'll just see what different combinations can be there. P, Q, R, S, and T. Now here P is thrice of T. Okay. So suppose if say T is T here, then it will be 3T. Then S is greater than Q by 4, and while Q is greater than R by 3. So if say R is say R, it will be R plus 3, and see S is 4 more than this means it will be R plus 7. Okay, so that are the restrictions here. Okay, so this is the basic information. Now another condition given is T is not equal to 0. So that means T can be 1, 2, 3, 4, etc. But again, for T, there will be some restrictions because P should be 3T. So if you take T as 4, then 3T will be 12, and which is not a digit. So maximum value P can have is a 9. So maximum value of T can be 3. It cannot be 0. So it can be 1, 2, 3. So we'll see now one by one. If T is 1, we'll see what happens. If T is 1, P will be 3T. So that is 3. Now we'll start with R. Now R cannot have value 1 or it cannot have 3, but it can have 0 because there is nothing mentioned as all distinct digits. So 0 is also a digit. It is not mentioned anywhere non-zero digits or etc. So R can be 0. But in this case, if R is 0, then R plus 3, it is 3. But then P and Q will be same. So this possibility is not there. Okay. So we can have R as 1, but here 1 is already there. So we cannot have R as 2 or 1 also. So it can be 2. R can be 2. So 2 plus 3, 5, and 2 plus 7, 9. So this is one number. 35291. Okay. The next possibility, see again R also there are some limitations. R cannot go beyond 2 because if you put 3 here, then R plus 7, 3 plus 7, 10, which cannot happen. So with this possibility, there is only one number. Now with P as 2, P2, then here it will be 6. Now here you can have 0 number. Okay, so if you have 0 here, then 0 plus 3 and 0 plus 7. So that is another number. 63072. Okay, you can have this 2 here, then 6 here. Okay, and then you can have 1 here. So 1 plus 3, 4, 1 plus 7, 8. Okay, you can have 2 again here because 2 is already there. So there will be only 2 numbers here, 6, 4, 1, 8, 2. Then you can have 3 here. 3 3s are 9. Okay, so again you cannot have 0 here because 0 plus 3 will be 3. So already there. So you can have 1. So 1 plus 3, 4. And 1 plus 7, 8. So 94183. Now here you cannot have 2 here. Say 3, 9. You cannot have 2 because 2 plus 7 will be 9, which is again same. So you cannot have this option. So there are only this 4 numbers. Okay, 1, 2, 3, 4. 4 numbers. So how many such 5-digit numbers are possible? It will be 4. So you have to do some trial and error with the given restrictions and some elimination process. X can complete 1/3 of a certain work in 6 days. Y can complete 1/3 of the same work in 8 days, and Z can complete 3/4 of the same work in 12 days. All of them work together for n days, and then X and Z quit, and Y alone finishes the remaining work in 8 and 2/3 days. What is n equal to? See, they have worked for all they have worked together for n days. You have to find out the value of n. So this is a time and work problem. So in C, X can complete 1/3 of work in 6 days. See, for X, 1/3 work in 6 days. That means full work he can complete in 18 days. 6 3 are 18. Okay, full work. He can complete in 18 days. For Y, he can complete 1/3 work in the 8 days. So 1/3 work in 8 days. So entire work in 8 3s are 24. So 1/3, 1/3, 1/3. So 24 days. Z, 3/4 of the work in 12 days. So Z is 3/4 work in 12 days. Okay, so the entire work will be 12 into 4/3. So 48/3, that is 16 days. Okay, you can just have ratio proportion. See, 3, 4 and 12. So 1 in how many days? So 12 into 1 upon this. So 16 days. Now, they all of them work together for n days. Okay. See, now X can complete the work in 18 days, means in 1 day. Okay, single day's work. Single day's work is 1/18, 1/24, and 1/16. Okay, he completes the work in 18 days. That means in 1 day he is doing 1/18th of the work. Y 24, so 1/24, and Z 16. Now they have worked together for n days. That means everybody has worked together for n days. So in n days, X will be in n days. X will be doing n upon 18. Y will be doing n upon 24. Z will be doing n upon 16. And plus Y has done. See, Y alone finishes the remaining. So Y has done for 8 and 2/3. So 8 3s are 24 plus 2, 26/3 days. Okay, so 26/3 days here, and see 26/3 into 24. So in n days, this will be the work done. Okay, and this is equal to 1 because they have done work. See, X work in 1 day, Y's work, Z's work in n days, and the remaining work, and the total work is done. So now here if you solve this, see here 18, 24, 26, etc. The LCM is how much? So you can just have here 12, 36. So LCM is 144. So if you multiply the entire equation by 144, okay, 18 8s are 24 6 are 16 9s are so 9n plus here 24 6 are so here see 36 4s are 144. So 13 4s are 52 is equal to 144. So 14 23n is equal to 144 minus this. So 92. So n is equal to 4. That means they have worked together for 4 days. N is 4. So time and work. Okay. See, for time and work, you should be able to work fast with the fractions. Okay, finding out the LCMs, etc., addition, subtraction. Mainly addition and subtraction of the fractions. So here you get it as n is equal to 4. So this is option B. What is x in the sequence? So one reasoning question, number series or sequence questions. 1, 3, 6, 11, 18, x and 42. So we'll just see here. See what is the differences between the numbers. X and 42. See here 1 and 3. The difference is 2. Here see the difference. It is plus 2. It is plus 3. Plus 5. Plus 7. So what you observe here is see 2, 3, 5, 7. They are all prime numbers, increasing prime. So next prime number is 11. So if you add plus 11, it should be 29. And then the series completes with 29 plus 13, 42. So the pattern is consistent. So that means our answer X is 29. So option C. So I think this time 2-3 such questions are there based on the sequence also and coding with sequence. So answer is 29 here. Consider the following statements. There exists a natural number which when increased by 50% can have its number of factors unchanged. See the number of factors are not the factors, number of factors. There exists a natural number which when increased by 150% can have its number of factors unchanged. Which of the following statements given above is or are correct? So I have to consider all the natural numbers, but again if you read the question carefully, the number of factors should not change. The factors themselves may change. Now again the number of factors should be changed. See if you we know that for prime numbers the factors are always 2. So most probably the number may be a prime number because what happens, see like number 4, the smallest composite number, it is 4. Okay, because see 1 is not a composite or prime, 2 and 3 are prime, so 4. So for 4 the factors are 1, 2 and 4. Okay. Now if you increase it by say 50%, okay, and then again 150%. Okay, what happens? If 50% increase means it will be 6. So the factors are 1, 2, 3 and 6. So the number of factors changes. Okay. But now if you consider a number, natural number n equal to 2. Okay, so its factors are 1 and 2. So number of factors is 2, 1 and 2. Then if you increase it by 50%, so 50% increase, means half of it is increased, so it becomes 3. Number becomes 3. The factors are 1 and 3. Then the second, so that means this is correct. The second one, there exists a natural number which will increase by 150%. So 150% increase means it becomes 250% or 2.5 times. So 2.5 times is, the number becomes 5. So again there are only 2 factors, 1 and 5. See the factors have changed but the number of factors, see we are interested here in the number of factors. So number of factors remains same, 2 factors, 2 factors, 2 factors. So there exists a natural number n which is 2 here, which is satisfying both the statements. Both the statements are true for that. So here the option will be both 1 and 2. So you will see mainly in many questions we have seen that there are some questions related to factors also. Factors, multiples, etc. So please do it thoroughly. The next question. There are 7 places A, B, C, D, E, F and G in a city connected by various roads A, B, A, C, C, D, D, E, B, F, E, G and F, G. A is 6 kilometers south of B, is 10 km west of C, D is 5 km east of E, C is 6 km north of D, F is 9 km, so on. And then what is the distance covered by the person? So different distances between different points are given, different places. So we'll have to draw a rough sketch for this and see what happens. So we'll go one by one, we'll take one pair. A is 6 km south of B. So suppose if B, we'll start from any point here, say B and C. So here this is 6 kilometers. B and A. Then next is A is 10 km west of C. So this is maybe C. So 10, A and B. 6 km B. Okay, D is 5 km east of E. So we cannot locate it right now. So we'll just leave that. We'll come back to it again. C is 6 km north of D. So C is 6 km north of D. So this is D here. Then come back to this. D is 5 km east of E. So D is 5 km east of E. So E will be somewhere here, halfway between this E. So this is 5. Okay, then next one is F is 9 km west of B. So this is there, 9 kilometers west of B. Okay. I think this is clear. Then F is 12 km north of B. That means G is 12 km south of F. See, if you observe here, see this 6 and this 6. So that will be, it will be in line with this E. Okay, on the same level. If, okay, now this is the case. Okay, final these things. A person travels from D to F through these roads. Okay, so D to, see this is D here, D to F. Now if you dot this, you connect this roads. Okay, because see EG is also a road. See this is 5 km here. See this, if you observe this is 5, so this will be again 5 and this is 9. So 9 plus 5 plus 5. Okay, this is 19 and then this is 12. Okay, so GF is 12. So 19 plus 12. So total distance traveled will be 31. Even if you go by this rule, say D this 6 plus 10, 16 plus 6. Okay, 22 plus 9, 31. So either by this route or by this route, the distance is 29. 31 kilometers. Right? See this 5, 6, 10, 16, 6, 22 plus 9, 31. Here this 5 plus 5, 10 plus 9, 19 plus 12, 31. So either way it is 31. So option C here. So you'll have to draw a rough sketch like this. In a certain code, if 64 is written as 343 and 216 is written as 729, then how is 512 written in that code? So again, this question is based on the cubes and squares. Yesterday also I told you the importance because see many questions this year itself we have found out at least 3 to 4 questions based on squares or cubes. Now see 64 is coded as 343. Now I will just write here the numbers is 64 and 343. Now if you 64 is also a square, it is also a cube also. It is cube of 4. So 4 cube and this is 7 cube. Okay. Next one 216 and 729. 216, 729. So 216 is 6 cube. This is 9 cube. So what you observe here is see 4 and 7. So 4 plus 3 is 7. 6 plus 3 9. So now next number 5 and 2. So 5 and 2 is 8 cube. So 8 plus 3 is 11. So by this same logic, see 4 plus 3 7, 6 plus 3 9, 8 plus 3 11. So 11 cube. That is 1331. So very simple. If you know the logic, you can just have it in say maybe 10 or 15 seconds. Okay. See there is just time to explain. I am taking more time, but you can just on your own you can just solve it very fast. See, you should be looking for such type of questions. If you want to have within 2 hours, you have to go for 80 questions. Okay, so first your priority should be solving such type of questions, which can be easily solved in 10-15 seconds. And then the remaining time can be utilized for other things like passages, etc. So this is the answer here. What is the remainder when 9 raised to 3 plus 9 raised to 4 plus 9 raised to 5 up to 9 raised to 100 is divided by 6? So now we'll break this into different parts. Okay. See 9 raised to 3 and 9 raised to 4. Okay. Yeah, see 9 raised to 3. Plus, first we'll concentrate only on this 9 raised to 3 and 9 raised to 4. So see, here this can be written as 9 raised to 3 into 1 plus 9. Now we know that 9 raised to 3 is 729 into 10. So that is 7290. So now this number, first we'll see whether this number is divisible by 6 or not. Okay, see what is the remainder. So if this number is divisible by 6, then remainder will be 0, or otherwise we can find out the remainder. But now if you see this number 7290, this is an even number, so divisible by 2, 7 plus 2, 9 plus 9, 18, which is divisible by 3. So since the number is divisible by both 2 and 3, that is the condition for divisibility by 6. This is divisible by 6. By 6. So remainder 0. Remainder is 0. Okay. Now see the next things. 9 raised to 5 plus 9 raised to 6. Okay. Again here from this I can take 9 raised to 3 common. Okay. See 9 raised to here see here this thing 9 raised to 3. See here basically it was 9 raised to 3 into 9 raised to 1. Okay. So here also what you can do is see 9 raised to see basically the 7290 you want that 7290 there. Okay. So how you'll write that? See you want that now 7 raised to 3 is see you can take it as 9 raised to 4 3 into 9 raised to 2 plus 9 raised to 4 3 or what? 9 raised to 2. 1 second. Sorry, I'm this. See here, basically what we are doing is we want to take it as 7290 into some power, into some number. So that will be how to you will be getting it is 9 raised to 1 and here it is 1. So 729 into 10, 7290. So which is see 7290 is 9 raised to 3 plus 9 raised to 4. So here if you take it as 9 raised to 2 here, so it will be 9 raised to 3 plus 9 raised to 4. See 5 divided by 2 and here 3. Now again we know that 9 raised to 3 plus 9 raised to 4 which is 7290, which is divisible by 6. So remainder is 0 and it will be multiple of this. So now if you make pairs of the further numbers, okay 9 raised to 7 and 9 raised to 8 etc. See for example 9 raised to 7 and plus 9 raised to 8. Okay, here also if you take 9 raised to 4 outside, so it will be 9 raised to 3 plus 9 raised to 4, which is again 7290. So divisible by 6, that means its multiple will be divisible by 6. So there will be like this such pairs, okay, which are all divisible by 6. So their addition, that number will be also divisible by 6, which means there will be remainder of 0. Okay, so if the number is divisible by a particular number, then in that case remainder is 0. So we have to break the larger problem into smaller parts, divide it into smaller parts and then tackle it. So divisibility test also you'll have to remember all the tests, divisibility tests like for 2, 3, 4, 5, 6 and so on. Okay, coming to the next question. A question is given followed by two statements. Okay, statement sufficiency or something it is called. Some statements will be given, one question will be given and you have to find out whether given statements are sufficient to answer the question or not. So here the question is, what is the smallest one digit number having exactly 4 distinct factors? And two statements are given. 2 is one of the factors. Statement 2, 3 is one of the factors. And now which one of the following is correct in respect of the above question and the statements? The first option is the question can be answered by using one of the statements but cannot be answered using the other statement above. Means one of the statement is sufficient to answer the question but other statement is not sufficient. The question can be answered by using either statement, means either statement 1 or 2. The question can be answered by using both the statements together but cannot be answered using either statements alone. Means you have to use both the statements. And the question can be answered even without using any of the statements. Now we'll see because the range of this is very smaller. Okay, we'll just see what happens to one digit numbers. See, naturally for 1, the factor is 1. For 2, the factors are 1 and 2. For 3, it is 1 and 3. For 4, 1, 2 and 4. For 5, 1 and 5. For 6, 1, 2, 3 and 6. So there are 4 distinct factors. So here itself we have got our answer. What is the smallest one digit number having exactly 4 distinct numbers? That is 6. So even without looking at the 2 statements, we have find out the answer. So here see the last option. The question can be answered even without using any of the statements. We have just used the question and the basic knowledge. So 6. So the option will be D here. Option D. Without using anything. See again these questions are repeated, means factors and multiples etc. Okay, next one. A question is given followed by 2 statements 1 and 2. Consider the question and the statements and mark the correct option. Question. Let PQRS be distinct non-zero integers. PP into PQ is RRSS, that means a 4-digit number, where P is less than equal to 3 and Q is less than equal to 4. Then what is Q equal to? Statement 1, R equal to 1, R equal to 2, and again options are given. Whether it can be used, means found out using one statement alone, both the statements are needed, or question can be answered even without using any of the statements. Now first we'll see whether from this information only, this question itself, if we can find out the answer. Okay, otherwise we'll be using the statements. See, P, Q and PQ, PP into this. P is less than equal to 3. See, P is less than equal to 3 and Q is less than equal to 4. Now PP, see, we want to find out the answers. See, P can be that means less than equal to 3. It cannot be 0 because 2-digit number. So P can have values 1, 2 and 3. R can have value 1, 2, 3, 4. Now see what happens. PP into PQ. See, you take P as 1, so it will be 1, 1 into 1. So even if you take the largest value here 4, okay, Q is largest value is 4. So 14 into this, it will be only say 154. So a 3-digit number. But we want the answer as RRSS. So 4-digit number. Okay, that means 11. P cannot be 1 here, so that is ruled out. 2 again. See, P 22 into again 2 and maximum 4. So 24 into this. So 480 plus 48. So 528. Okay. So again it will be a 3-digit number. Now next P as 3. So 33 into 3. Okay. Now again see if you take 31 into 1, then that number will be how much? 990 plus 3. So 3 there is a 9. Okay. See, just you can take it 33 into 30 is 990 plus 33. So 1023. So which is a 4-digit number, but it doesn't satisfy this condition. So now if you go on checking for 33 into 32, 33, 34. So the first number you get is 33 into 34. Okay. See now 34 here it is 1 here 3. So 99 you have to add to this number to get our new number. So 1122. So which satisfies this condition? See 1122. Okay, so without using this question also we have found out the value of Q. Okay, so now Q is what? 4 here. So you have to do some trial and error but with some eliminations. Okay, so basically you should know this 11 into 14 cannot give you a 3-digit number. Okay, see basically you see 30 into 30. Square of 30 is 900. So any number less than this will not give you a 4-digit number. So that is why I have ruled out this 22, 24, etc. So first thing is 33 into 31. And then you get these numbers as 34. So Q is 4. So again the question can be answered even without using any of the statements. Option D. Okay, question given followed by 2 statements 1 and 2. Consider the question and the statements and mark the correct option. How is Q related to P? So this is based on the relationships, blood family relationship question. P has two sisters, R and S. See now here no information is given. How is Q related to P? So from this statement alone we cannot be able to answer the question. So at least we should have one statement. So P has two sisters, R and S. Okay, now we'll see how to go about this question. P has two sisters, R and S. So P, R and S. So female and female. So they are siblings, but from this alone statement alone, because there is no mention of Q there. So statement 1 alone is not sufficient. So statement 2, R's father is the brother of Q. Okay, so that means they are siblings now. So R's father. Okay, so whoever is his father is brother of Q. But again, see here, this father, R's father is brother of Q, but no mention of gender of Q. So whether Q is a male or female. Okay, because see the question is how Q is related to P. So we should be able to find out Q's gender. Because see for P, if Q is a lady, then she will be paternal aunt. If Q is a male, paternal uncle. So to know exact relation, we should know whether Q is a male or female, but which is not provided here. So here the question cannot be answered even using any of the two statements. So you, many times in blood family relations, you just draw a family tree or family chart like this page. So it will be much easier. Okay, so option D. We go for the next. A question is given followed by two statements, 1 and 2. Consider the questions and statements and mark the correct option. In a football match, Team P playing against Q was behind 3 goals within 10 minutes. Does Team P win the match? So two statements are given. Just go through them. Okay. See, P playing against Q was behind 3 goals, 10 minutes remaining. Does P win the match? See, from this statement alone, you will not be able to find out. So we'll see the statements. Team P scored 4 goals in the last 10 minutes. But before that, see, P means before up to last 10 minutes, what was the situation? P was 3 goals behind. That means the situation can be something like this. Say P and Q. It can be 0 and 3. It can be 1 and 4. It can be 2 and 5. It can be 3 and 6. Any one of the combination. From this. Now let us go one by one. See statement 1. P scored 4 goals in the last match. Last 10 minutes. That means see, if this is the situation, P was leading by only 3 goals and Q has done 3 goals. So if P scores last 10 minutes 4 goals, then the result will be 4 and 3. But here it is not mentioned whether Q has scored any goal in the last 10 minutes or not. So statement 1 alone is not sufficient to answer the question. Second statement, Team Q scored a total of 4 goals in the match. Okay, so if you consider only the second statement, see Q has scored 4 goals. P was earlier 3 goals behind. So if this is the situation, okay, in this only on the based on the second question, I am talking now. See, you can just rule out this too. So 3 goals here, P has scored 1 more goal. But whether Q has scored any goal or not in the last matches, okay, last 10 minutes, it is not mentioned here. Now, if you club both the statements, that means P scored 4 goals in the last 10 matches, Q scored a total of 4 goals in the match. Now, there may be 2 cases, see like this, because Q has scored a total of 4 goals in the match. So, suppose in the before 10 minutes, say 10 minutes. Okay, see first part. Okay, suppose if this is the case that P is leading by means trailing by 3 goals, 0 and 3. Now team P scored 4 goals in the last 10 minutes. See here, I will write it here. See, this was the earlier case in the last 10 minutes. Okay, P scored 4 goals and Q total scored here 1 goal, so 4 and 4. So it is draw. Okay, but if this is the case, say 1 and 4, as I already told. Okay, see, suppose before this, P was trailing by this 1 goal here. Then in the last 10 minutes, Q has scored 4 goals. Q has not scored as this 5 and 4. Okay, so here P wins the match. Here it gets draw. Okay, so from both the statements together also, we will not be able to tell whether P has won the match or not. It may be won, it may be lost also. So the question cannot be answered even using any of the statements. So here also the option is D. A question is given followed by two statements. Again, the data sufficiency. So I will not just read all the options. I will just see this question. P plus Q square minus 4PQ, where P and Q are natural numbers, positive. Means you have to find out whether this P plus Q square minus 4PQ is positive. See, from the statement alone, we will not be able to tell whether it is positive or no. Okay, so we'll just break down the statement first. P plus Q square minus 4PQ. Now, if you expand this, see, this is P plus Q square means P square plus 2PQ plus Q square minus 4PQ. So that is P square minus 2PQ plus Q square, which is P minus Q square. Now the question is whether this is positive, that means greater than 0. Now we know that square of any number, whether positive or negative, is greater than 0. Okay, that means if P is less than Q or Q is less greater, means P is less than Q or P is greater than Q. In both the cases, the square will be greater than 0. But if P is equal to Q, then it will be 0. So it will not be positive. So here nowhere it is mentioned that whether they are distinct or what. Okay, but see the statements now. If statement 1 is given, P is less than Q. So P minus Q will be negative, its square will be positive number. Okay, greater than 0. P greater than Q. In this case, this itself is positive, so its square will be positive and greater than 0. So if you get either first statement or second statement alone, you will be able to give the answer. So now we will see this option. The question can be answered by using either statement alone. Either you can use the first statement or you can use the second statement. So here the concept that square of any number, positive or negative, is always positive. That you are using. And of course, this algebraic expressions. Okay, a plus b square, a minus b square, a plus b cube, a minus b cube, etc. So that we are using it. So option is B. It can be answered by any statement alone. Okay, next question. In a T20 cricket match, okay, right now it is going, say IPL and all those things. So 3 players X, Y, Z scored a total of 37 runs. The ratio of number of runs scored by X to number of runs scored by Y is equal to the ratio of number of runs scored by Y to number of runs scored by, it should be, this should be Z, huh? Sorry, it should not be A, the question is Z, because there is nowhere mentioned A. Okay, now different values are being given. See, runs scored by X, value 2, runs scored by Y, value 3, runs scored by Z. Which one of the following is correct? So 4 options are given. So first, our first task will be to finding out value of this value 1, value 2, value 3, etc. Okay. And then we will be going for the options. See, the first thing, the scores, the X plus Y plus Z. X plus Y plus Z is 37. And what they have mentioned is the ratio of number of runs scored by X to the number of scored by Y. X upon Y is equal to ratio of number of runs scored by Y to number of runs scored by Z. So this is the ratio. So from this we get Y square equal to XZ. And again X plus Y plus Z should be 37. So now we will be having different options for Y. And we will be restricting or limiting our range of the null values. You see what's happening. Suppose if Y is equal to 1, then Y square will be 1. But then XZ cannot have the product of 1 because they should be also 1, 1. But then in that case, X plus Y plus Z cannot be 37. Okay, if next thing, any other value of Y, okay, for example, say Y equal to 2. So Y square will be 2, but again, it can be 1 and 2 or 1 etc. So it cannot be 37. So y's value should be sufficiently larger, but at the same time it cannot be much larger. Okay, because see maximum value of y, suppose y can have say 15. We'll I'm just trying to limit our range. So 15 square is 125. Okay, but then again the 125, the factors can be either 5 into 25. Okay, only one possibility, but then 25 plus 5 plus 15, it is larger than 37. So we cannot have that one also. So see here, y square equal to xz. Okay, so x plus z plus y. So now from this, we will be having the range of y, say approximately up to 1/3 of 37. If it is there, then it can be have that. So we will have try with those two values, say 12 and 13, approximately 1/3 values. So if y is 12, so y square will be 144. Now for this, we will have to find out factors of x and z. See 144. So the factors can be say 144, 1 and 144, 2 and 72, 3 and 48, then 4 and 36, 6 and 24, then what? 18 and 18, or 9 and 16. But now see, y is 12 here, huh? Y is equal to 12. So 12 plus 1 plus this. See, up to this, you have to just omit 36 plus this. Okay, so you can have this four options, you are eliminated. 26 plus 24 plus 6, 30 plus 12. So this is also eliminated. 18 plus 8 plus 12. All the options are positive, I mean even. So you cannot have all total. So see here, 16 plus 9 plus 12. Okay, 25 plus 12, 37. So that is one combination which we have got. So y equal to 12 and x and z 9 or 60. Okay, so x, but here again, see, there may be two possibilities, or 16 and 9. So y 12, 12. Okay, so y has 12, x has 9 and 16, 12, 16 or 9. So now see here. So this is value 1. Okay, so if you see this, value 1 is this. So I will just write it here. Value 1, 16, value 2, 12, value 3, 9, or it can be 9, 12 and 16. So see, as per this, value 1 less than value 2 less than value 3. But as per this, it is value 3 less than this and this. Value 3 less than value 2 less than value 1. But there is no option. We will not be able to determine exactly whether x is 9 or z is 9 and vice versa. So here it will be cannot be determined due to insufficient data. Okay, so again squaring things, and you will have to eliminate your ranges. So cannot be determined due to insufficient data, because we are not able to exactly pinpoint the values of x and z. Okay. P plus Q is equal to 10, where P and Q are integers. So we know that integers will start with 1, 2, 3, or 0, -1, -2, -3, etc. But not the fractions. Value 1, maximum value of P into Q when P and Q are positive integers. Second one, maximum value of P into Q where P is greater than equal to -6 and Q is greater than equal to -4. Which one of the following is correct? Value 1 or value 2, etc. Okay. So again we will see, just go one by one. See, P plus Q is 10. So we will have just values of P and Q here. See, P and Q. So it can be 1 and 9. It can be 2 and this. Okay. 2 and 8. It can be 3 and 7, 4 and 6, 5 and 5. Okay, and 6 and 4, etc. 6 and 4, etc. So on. But again, see the product. See here, the product is 9 PQ. Here it is 16. Here it is 21. Here it is 24. Here it is 25. Here it is 24. Then 7, 3, 8, 2, 9, 1. So 21, 16, and 9. So the maximum value is 25. So value 1 is 25. Okay, this is value 1. So I will just write it here. Value 1, 25. Is it visible? So I will just write it here. Value 1. Now see the second value 2, maximum value of P into Q when P is greater than equal to minus 6 and Q is greater than equal to minus 4. Okay, so again see P and Q, again the restriction is P plus Q is equal to 10. So if you take one value as positive and one value as negative, see because these values are starting with minus 6 and minus 4. So P greater than equal to minus 6 means P can be minus 6, minus 5, minus 4, minus 3 or P can be plus 5 also. Same way Q is greater than equal to minus 4. So Q can be minus 3, minus 2, minus 2, minus 1, 0 or it can be also 5. So again in this two conditions also the maximum value or the value can be 5, so the product can be 25 again. So it will be value 1 equal to value 2, maximum value. So that means the option C here. So number line and number system. Okay, again this question is based on that. So value 1 equal to value 2. Consider a set of 11 numbers. Value 1, minimum value of the average of the numbers of the set when they are consecutive integers greater than equal to minus 5. Second value, minimum value of product of the numbers of the set when they are consecutive non-negative integers. So we'll go, see one by one value. Minimum value of the average of the numbers. See, for the value to be average means value of average should be minimum. The sum of the numbers should be minimum. That means we should take the smaller numbers within the given range. See, our consecutive integers greater than equal to minus 5. So if you take the 11 integers as this, see minus 5, minus 4, minus 3, minus 2, 1, 0, 1, 2, 3, 4 and 5. So 11 numbers, negative 5 numbers negative is 0 and 5 positive numbers. So total 11 numbers. Now total of this, see minus 5 plus 5 0, minus 4 plus 0. So the sum is, sum of numbers is 0. So average will be 0 upon 11, that is 0. So this is value 1. Okay. Now see the second part. Minimum value of the product of the number of the set when they are consecutive non-negative integers. Okay. See, the word used is non-negative integers, but that means 0 can be there. Okay. 0 is non-negative. So if you take minimum value of the product of the numbers of the set, so you can start with say 0 into 1 into 2 into 3 into 4 into 5 into 6 into 7 into 9 into 10. So 11 integers will satisfy this condition. Okay, they are consecutive non-negative integers, so which can include 0. But here the product is again 0, which is value 2. So it is just a tricky question. Many times the people make mistake of taking it as 1 to 11. Then in that case it will be a positive number. Then values will change. Value 2 will be greater than value 1. But since here the word used is, this is important, non-negative. So 0 is a non-negative integer. So here again value 1 is equal to value 2. Option C. So please go through the number systems. I am again repeating it again and again. Number systems, HCF, LCM, etc. Because see, so many questions we have seen in the last session and today's session also are based on the number systems. Okay, real numbers, integers, natural numbers, etc. So this is the case. Now next, average of three numbers P, Q and R is K. P is as much more than the average as Q is less than the average. What is the value of R? Okay, the average is K. Okay, so again we will see how to go about this. See, average of the three numbers, average of P, Q, R. That means P plus Q plus R upon 3 is K. So P plus Q plus R is equal to 3K. Now, the average of three numbers P, Q, R is K. P is as much more than the average as Q is less than the average. Suppose P is X more than average. So Q will be X less than the average. Okay. So here P is X more than the average. Okay, and Q is x less than the average plus k minus x. Okay, plus R is equal to 3k. We have to find out the value of R. So here see k plus k is 2k, x minus x 0. So 2k plus R is equal to 3k and R is equal to k. So it is equal to the average. So here see, I have written it to explain here, but if you just go logically, P is more than the average, Q is less than the average by the same amount. So if you add these two, they become 2 times of the average. So naturally the third number should be equal to the average. Because if it is more or less than the average, then the average can be here K. So that is the main concept here, average. So its value is K here, the option 1, A. Let x be a real number between 0 and 1. Which of the following statements are correct? X square is less than x by 3, etc. See, a real number between 0 and 1. Okay, so its range can be, see, 0 less than x less than 1. Okay, that means it is a positive number. So for okay, so now first one, x square is less than x cube. Now, if you square on C, now we know that x, suppose say if x is between this range, if you take this value as 1/2. So x square will be 1 by 4. Okay, which will be less than this number. Okay, so in this case, if x is less than 1, x square will be 1 by 4. So x square will be here, what is the, will be less than x. So here if you multiply on both the sides here, okay, see if you multiply on both the sides, so x cube will be less than x square or x square is less than x cube. So first statement is correct. Okay, that is the first statement here which is correct. But now since the option is both 1 and 2, so you'll have to check for x square greater than minus x also. Again same thing here. See x greater than square root of x. See, since both x and square root will be also positive, so if you multiply it by positive number, the relation will not change. Okay, so if you multiply on both the sides here, if you square on both the sides, okay, so it will be x square is greater than x. Okay, but see, we have already seen that for positive numbers, x square is less than x, and here we are getting x square is greater than x. So which is contradictory. That means this is not correct. So only statement 1 is correct. Okay, option A. So we have ruled out that second option. So both 1 and 2 is not correct. Neither 1 nor 2 is also not correct. Only one option, x square is greater than x cube. See, this can be written as x square is greater than x cube. The first option. Okay, and coming to the now last question here. The difference between any two natural numbers is 10. What can be said about the natural numbers which are divisible? The natural numbers which are divisible by 5 and lie between these two numbers. Oh, sorry. So we'll consider any two natural numbers. See, suppose the natural numbers are say 1 and 11. Okay. See, difference between any two natural numbers is 10. So 1 plus 10, 11. Now, how many natural numbers are there between these two numbers which are divisible by this? Divisible by 5. So it is 5 and 10. Okay, between, it is between these two. That means you have to exclude these two numbers. So it is two numbers. But if you take, see, take another case, say 6 and 16. So again, there are two numbers, say 10 and 15, which are divisible. But if you take, say, these numbers 20 and 30, there is only one number which is divisible. Okay. So now see this option. There is only one such number. As per this, it is correct, but there may be two. There are only two such numbers. Again, it is not this thing. There can be more than one such number. See this one number which is referred by divisible by 5. So it can be either one number or it can be two. So the option will be there can be more than one such number. So option C. Okay. So this is the last question, 80 number of questions. So that is the it. So now again I will request you to go through this videos again. If there are any questions or doubts, you can always revert back. Okay, you can send your queries to Dhruva and we will clarify it. But the main important point I want to tell you is focus on this number systems, then the spheres, cubes, etc. I'm again repeating it again and again, the cost of repetition. But that is important as you have seen always. So please do it carefully. And again, as a strategy, see there are now 51 questions based on this CSAT, etc. 29 questions on your passages. So in this 51 questions also, you focus on those questions which can be solved easier and in smaller time. Like see in this question, okay, only some basic concepts should be known. There is no much calculation. So try to avoid or try to keep the questions which are based on the calculations like interest or that time and work, etc. the last. If time permits, you can always solve it. Okay. So that's it, I think. So wish you all the best. That will be last things. Okay. Thank you. Wish you all the best. So, you have a question?